In this video, we're going to look at the formula for specific heat. So our first variable is the quantity of heat being added. So since this is a quantity, the symbol for this is Q. And since this is heat that we are talking about, our symbol or our unit is going to be joules, which is represented with the letter J. The next variable is specific heat. Specific heat symbol is the letter C. Its unit is going to be joules over grams per degrees centigrade. The next variable is mass. Mass's symbol is M. Normally we measure our units in kilograms, but in this instance we are going to measure it in grams. And then our final variable is the change in temperature. So our symbol for that is delta T, and our unit is degrees centigrade or degrees Celsius. All right, here are a couple of specific heats of known metals. So iron, as you can see here, is 0.449. Water is 4.184. Silver is 0.233. Wood is 2.3, and glass is 0.84. The purpose of this is to kind of show you the difference between metals and non-metals. So metals like iron and silver have a very low specific heat, so it takes very little energy to increase their temperature. Unlike water, wood, and glass. Glass isn't as good of an insulator, but these are your non-metals, and so they take more heat to raise the temperature for it. So like water is a fairly good insulator. Okay, for our first problem that we are going to look at. So an iron skillet has a mass of 500 grams, so that is our M. And the specific heat of iron we know is 0.449 joules per gram degree centigrade Celsius. So that's going to be our specific heat. We want to know how much heat is being added to raise the skillet's temperature by 95 degrees Celsius. So that's going to be our delta T. And what we're looking for is how much heat. So that is what our Q is going to be. So if we look at our formula, our formula is Q equals M times C times delta T. And so when we look at these, our mass is 500. Our specific heat we know is the 0.449, and our change in temperature is the 95. So once we write that all out, we're going to multiply all three things together, and what we end up getting is somewhere right around 21,328 joules. And I rounded mine to the nearest whole number. Okay, for the next problem. So we want to know how much heat is needed to raise the temperature of 100 grams of water by 85 degrees Celsius. So first off, we are looking for how much heat is needed to raise the temperature. We know the mass is 100. We know the delta T here is 85. And lastly, if we look up above problem 1, we can find the specific heat of water. The specific heat of water is 4.184. And so now you need to write out your formula. Your formula, again, is Q equals M times C times delta T. And then when we plug in all of our variables, we know our mass is 100, our specific heat is 4.184, and then our temperature is 85. And then when we do the math for that, we get 35,258 joules because we rounded. Okay, for problem 2. So we want to know how much heat is absorbed by a 750 grams iron skillet when its temperature raises from 25 to 125 degrees Celsius. So first thing, we're looking at how much heat. So we're looking at how much energy is being absorbed. We know the 750 is our mass. We know the 25 is going to be our initial temperature. That's the starting temperature of the skillet. Then that means the 125 is going to be our final. So first thing we need to do is we need to calculate out delta T. We also know for iron that our specific heat is 0.449. So you can just jot that down off to the side. But like I said, we need to find the delta T. So remember, to find delta T, that is the final minus the initial. So it's going to be 125 minus 25, which gets us 100 degrees Celsius. So this means we can now move on to our specific heat formula. So Q equals C times M times delta T. Again, I have flipped these two. It doesn't matter the order of them. You could write it in any particular order because you are multiplying them together. So we know that our specific heat is 0.449. We know our mass is 75. And we know our change in temperature, which we calculated over here, is 100. So we know that the amount of heat needed to increase this cast iron skillet by 100 degrees Celsius is 33,675. Last problem. So a jeweler heats 10 grams of a silver ring by adding 23.5 joules of heat. How much does the temperature of the silver increase? So we know the 10 grams is our mass. We know the 23.5 this time is our heat because it's joules. We want to know the temperature change, and we know the specific heat of silver is 0.233. So to start off with, we are going to have our formula here. So we know Q equals M times C times delta T. If we plug in our numbers, we know Q is 23.5. We know our mass is 10. We know the specific heat of silver is 0.233, and we're looking for that change in temperature. So now what we're going to do is I'm going to multiply 10 by 0.223, so I get 2.33. And then to get the T by itself, I'm going to divide both sides because we're multiplying here. So the opposite of multiplication is division. So we're going to divide both sides by the 2.33. And what we end up getting is this. So 23.5 divided by 2.33 equals our change in temperature. So our change in temperature comes out to be right around 10.09 degrees Celsius. For the rest of the 4 problems that are on the paper, finish them. They are your homework. Please turn your notes into the basket. If you did not finish the first page of notes, they are posted on Schoology under the thermal energy notes. Record those, and I will grade those as well. If you did not get them finished, I will correct the grade and give you points back for getting it completed.